why is it doing that? Okay, let's talk about this topic of using GenAI to generate SQL. So we're going to cover a few topics in this session. First about me. My name is Kaycee Lai, I'm the founder of Prometheum. And we've actually been doing text-to-SQL or natural language generated SQL for a number of years now. Prometheum's been around 6 years or so. Before that, I had my background in data infrastructure, data analytics, and most recently data cataloging with Waterline Data. So one of the things I always wanted to do was leverage the power of, say, discovery in a catalog where you have a lot of natural language expressions, especially in annotations and tags, to go one step further and actually help customers answer questions, being able to leverage their own data. But that was actually really hard to do, and so no one was doing it. So we actually started this process of doing, text-to-SQL by leveraging just natural language. So, fast forward a couple of years, right? Really happy and excited that, people have really latched on to GenAI and LLMs. And a big part of this is really being able to use natural language so that you can generate SQL. So we're going to cover this topic here today, and we're going to cover a few things because I think this is actually a pretty broad topic, pretty deep topic. And by the way, this will be a series, so we're going to get deeper and deeper as we go from episode to episode. But the first one is, well, how does it actually work, right? How does someone use GenAI? And how does someone use LLM, and how will it actually create SQL? What are the pros and cons, right? What are the benefits? I think the benefits are pretty clear, but what are the challenges that you can encounter as you start adopting this for your enterprise, within your own actual data? And then learning different ways that you can actually apply your LLM to do text-to-SQL. And what are some of the implications of those different implementations? Because there's a lot of solutions out there. Everyone does it slightly differently, and everyone not only does it slightly differently, but you also get different outputs. And so the outputs matter because depending on your role in the organization, depending on what you want to do with the output, you need to pick the right solution for you. Afterwards, we'll also kind of look at a live demo as well in terms of how the Prometheum Data Fabric would do it, and then leave some time for Q&A. And again, whatever we don't cover in this episode, we'll cover in the next episodes. Okay. So there's really three parts when you think about kind of GenAI generating text-to-SQL. Very easy at a high level, right? There's the user input, which is really the natural language prompts. So example would be someone types a question in English, in Spanish, in Japanese, doesn't matter, right? Hey, what are the revenues from plan X over time, over some dimension, over some group by? That's fairly straightforward. I think most people understand that. Or show me, or tell me, or I'm trying to look for X. We've all used public LLMs like ChatGPT, very, very natural. So what happens in the background, right? If you're using this against, say, your data warehouse or data lake, well, what happens is your systems probably has some NLP processing in there where it's going to parse the natural language to really understand what you're trying to do. What's the context and the intent of what this user is asking? Because that actually is very important for it to suggest how you should construct the SQL. And so part of the NLP process is this process known as tokenization, where it basically breaks down the keywords into tokens that makes it much easier to search and find the relevant data, right? So this is the named entity recognition. So, oh, what you said this from March to December. Okay, March and December is a date. I'm going to look for a date column, right? That would be an example of that thing, but looking for the relevant elements for you to build the SQL. And then the last part is the actual SQL generations. Like now that I kind of understand your intent and the context of your question, and I think I've identified from the tokens I've matched to some of the keywords that you're looking for, how would I construct a corresponding SQL statement, right? And so the LLM, the good part is it's got a library. It's been trained on a lot of different data, right? Probably a lot, big library of SQL expressions. And so it can suggest a SQL expression to match the context that you're looking for. And that's what you get as an output is you ask the question, and this is all happening in real time in the background. Boom, it spits out a SQL statement. But this is where you need to verify the SQL statement actually is correct and actually can execute. Because some LLMs will give you the SQL statement, but they're not executable. And we'll talk about that in a little bit, right? So those are the three main types, right? Three functional areas in terms of how GenAI generates SQL statements. Now, I think the benefits are pretty obvious, but we'll spend a little bit of time on them, right? One is obviously efficiency. Hey, if the machine can write 200 lines of SQL for me, right, in a minute, in less than a minute, why not? Why not have the machine? Just, I can do it, sure, but if something can do it that much faster than me and I don't have to spend that time, then it frees up time if I'm a data engineer or data analyst to go do something else or tackle something more important. So I think everyone understands the efficiency. The second part I do think is very important is if you start using, right, an LLM, an approach to do this, and you start standardizing this within your organization, then you've also standardized the production of SQL statements in your organization, right? Which every time you standardize something, you have a formal process, it always leads to more accurate results, right? Because it leaves less variance for individual differences, which those of you that write SQL, I'm sure you know that there's a bajillion different ways you can write a SQL statement to get the same answer. And depending on the data warehouse, database, data lake that you're working with, the SQL syntax could change. And so having a way to sort of standardize that SQL generation output actually does help with better quality, right? And minimizing the error, right? Whoops. That is so weird. Okay. And the last part I think is super important is the accessibility, right? Why people are very interested in this area is it allows non-technical people to actually take that one step further, right? To be able to ask the question and get the SQL statement and then be able to run the query and get the results. And so it does help streamline and make the whole process more efficient, but it also helps reduce the backlog from the already burdened data team as well. So these are obviously the great benefits of why someone would want to do this. Makes a lot of sense. I don't think anyone would argue that any of these are bad things. But here's some things you need to watch out for, right? One is we've all heard about hallucinations, right? When using LLM, we've all probably experienced it with something like ChatGPT. So relevancy and accuracy is actually a big part. When you do generate that SQL statement, how can you ensure it actually picked the right data? How do you ensure that the SQL expression is actually accurate? That's something that you really need to pay attention to. And so just looking at a SQL statement is not enough, right? You do need to execute it and you do need to see the output to make sure it's good. And then the next thing is, well, if it's not 100% accurate, which, a lot of times it won't be, especially the first time, and that's okay. That's okay if it's not 100% accurate. If it got you 80% there, but it got you there in a few seconds, it does save you a lot of time, right? I think what's important now is, does it explain how it got there? Does it show you, this is what I picked, here's why. I did this expression, here's why. And then you can see, well, maybe it was my prompts that confused it. My inputs confused it, and so I'm going to change how I ask the question. Or it could be, okay, obviously the machine made a mistake. I'm going to, we need to go train the model even more, train the LLM even more, and make sure it's more accurate. And then, is there a way for me to make changes on the spot? Is there an easy way, right? Is there a no-code way as well as a code way to make changes on the spot? And so that way you're doing reinforced machine learning and the system is getting smarter. That's important to think about, right? And then the other part is your data changes, unfortunately, in an enterprise, right? Where the data is located, it might have moved, the schemas might have changed, the metadata might have changed. And so you need to think about how that is going to impact the LLM. When was it last trained? Is it always updated? Because based on that, it could actually change the selection of the data that you have. So these things, especially one of them is enough to trip you up. Three of them combined can really trip you up. And I would say it's not the end of the world, but to a layperson, a non-technical user, they might get frustrated if they start seeing this the first time, the second time, the third time. You lose trust and you lose faith in the system. Now, they're all explainable and they're all fixable, but I think these are just things you should watch out for when you're implementing these. Like, how do I minimize this? Or how do I set realistic expectations? Or maybe, maybe when you first start, maybe the non-technical business users may not be the first place to start, right? Maybe you start with the builders, people who have enough context, people who know how to do the error handling, people who are not fazed by the fact that, hey, it got 90% of the way through. I just need to fix the 10% and it's going to get better and smarter. So those are some suggestions that we've seen that are very helpful that might be good for people to think about as they think about adopting this. Now, you can't talk about LLM and text-to-SQL without talking about, right, RAG, right? This architecture that we're all used to now in terms of doing retrieval augmentation. So here's just an easy kind of basic diagram to kind of show you kind of what it does at a high level, right? At a high level, you will make an input, an NLP, natural language input, to the RAG system. This is like asking your questions or typing your questions, for example, right? The RAG system will interact with your systems of record. Like it could be connected to your database or your data lake or your data warehouse. So it's going to try and search for the relevant information, retrieve that relevant information back, and then that prompt and the data in that context, right? It's going to send to the LLM, and the LLM generates the output, which in this case, what we're talking about is a SQL. So this is what's really going on behind the scenes. Again, high level diagram. We can dive deeper in future sessions. But this is what's going on. This is why it's more powerful than, say, just directly asking a question against your database. Now, when people talk about text-to-SQL, there's really two basic types that we should think about and delineate, because I think we kind of blur the line a little bit and people kind of use them interchangeably. So on one hand, there's text-to-SQL where you're going to use GenAI to build a data set out of raw tables, right? And then the other one is you're actually going to do the text-SQL off of a pre-built, pre-curated data set. So there's two types, right? And this matters because it matters in terms of who the consumer is. It matters in terms of who the doer is as well, right? So it also matters in terms of the degree of difficulty, right? On the left side, where you're going to use text-to-SQL to build that data set out of raw tables. So no one's ever built the data set before. No one's built the query before. It's just pure raw tables there. This is the harder part to do, right? But I argue it's the most valuable one, or the more valuable one, because once you have the data set, then analytics becomes possible, right? Whereas if you didn't have the data set, it becomes hard or almost impossible to do analytics well, right? The second type, which is where a lot of vendors focus and have focused for a while, and you probably see this in BI tools as well, is once you've given me that perfectly curated data set that's already been generated, right? And it's sitting on now one data warehouse or one data lake for my BI tool to connect to, then I can ask a bunch of natural language questions against it. And of course, my range, my variability is going to be just limited to whatever is available, right, in that curated data set. So if I have 10 columns, I can only ask questions against those 10 columns, right, in that data set. So obviously, you're going to have a much better end user experience because the variability has been reduced and limited. But at the same time, you're now waiting for this data set to be created first before you can actually do any type of natural language consumption. That's kind of the trade-off, right? So you have to think about which one is and then again, it's not saying one is necessarily better or the other, because I think for a lot of business users where you want that awesome out-of-box experience, maybe, right, the easier part of generating on pre-built, pre-curated data sets is an easier way to start, right? But in terms of unlocking value, in terms of helping reduce the backlog off of the data team, right? I think the one on the left, the text-to-SQL, in terms of building data sets out of raw tables, that's the more valuable and more powerful. Okay. So look, the great thing is, in the last year or year or two, we're starting to see a lot of capabilities being now built into, say, your data warehouse or data lake, right? So here, I just have screenshots of Databricks, Snowflake, and Dremio. So you can see they all have text-to-SQL capabilities. It's built right there in there. You click a little button and you start typing the questions or doing your pre-filter selections, and you're able to get the output very, very quickly, right? I like these implementations for a few reasons. One is there's nothing you need to do, right? The LLM's already packaged in there. You don't have to go think about picking your own LLM. Now, that could be good or bad depending on some organizations. Some organizations really like a specific LLM, and then you're going to have to work configuring to see if these vendors will let you use a different LLM. But two, because it's already pre-packaged and pre-configured in there and probably even pre-trained, performance is actually really good, right? Really good. If you use these products, you'll see the minute you ask a question, boom, you get a SQL statement. Like, there's not a lot of thinking that it has to do, right? So that's actually the cool part. But that comes with a price. So one of the things you do need to realize is that it's not as easy as just throwing an LLM against your data warehouse, data lake of choice. Because within an enterprise, most enterprises that we see, not all your data is in Databricks, is in Snowflake, is in Dremio. Not all our data, maybe even in one cloud or one data center, right? And so how do you make sure the question that you're asking is going to find just the relevant data? And if the LLM only works against one source, how are you making sure that it's going to be relevant retrieval? Two is a lot of enterprises, especially if they've been around for a while, the data is kind of messy, right? You have nondescript table names, nondescript column names might be duplicated, table names might be duplicated. If I say I want to know revenue and there's 10 revenue tables, which one do you pick? If I want to know revenue and there's 60 revenue columns, or some tax revenue, some service revenue, some product revenue, etc., how does the LLM know what to pick? How would it figure that out? That's the hard part once you get into an enterprise and once you start saying, how do I use my LLM against my actual enterprise data? And then how do I know, even if I did the name selection properly, how do I know that this data is actually useful, right? How do I know this data set was properly assembled, put together well, and that this is actually the one that people in my organizations want, right? So the first three are, kind of a little bit near dear to my heart, and anyone who spent time in kind of the metadata management world, data catalog and governance world, like that's kind of what, we do in that persona in terms of like you do a lot of work in the enterprise with that team to say, this is the trusted data, this is the trusted data source, this is the trusted column. We've looked at lineage, we've looked at crowdsourcing, we mapped it to our ontology, all that good stuff. You kind of don't get that when you just apply your LLM against your data warehouse. So that's one of the big gotchas, right? And then the last one, again, is kind of going back to the first one is, well, because you can't search across multiple data sources, you're also not going to be able to combine data from multiple data sources. So it assumes that you will always, if you're going to use GenAI, you're always going to have to move the data from another location into your data warehouse or data lake that has the LLM. May or may not be possible. You may or may not want to wait that long. So these are, again, not saying it's bad. It's just these are just considerations that you need to have because it does have an implication in terms of the output and who can consume the output. And so just kind of a quick scan, and there are many, many more vendors, but we kind of just looked at a few of the big ones. Azure, right? Databricks, Dremio, Amazon Redshift, Snowflake, and kind of looking at, what they can do, right? And so you remember what I talked about earlier is like, hey, there's some that can do text-to-SQL to generate a data set. There's some that can do just, text-to-SQL from raw tables, right? And so which ones can do which? This kind of shows you which ones can do which. For example, Azure and Dremio, you kind of need a data set pre-built first, and then it does a really good job doing generating ad hoc queries against that. But if you just have raw tables, they don't really work so well. And then there's the other considerations of how extensive is the SQL generation capability, because as we all know, SQL is a very, very robust language. And so, for example, with Azure, what we've seen is it only supports the generation of select statements. And so if you have a question that requires joins and unions and filters and group bys, that may not be ready for you right now. And I'd say may not be ready. I'm not saying they'll never have it, right? Because if you look at the deployment, to be fair, a lot of these solutions are in preview or public preview. So just want to be clear that I'm sure they will all get better, but just in terms of right now, what you're seeing. Databricks I actually really like. It's got a lot of holistic capabilities, very, very extensive. My one complaint about Databricks, and I'm sure they're already working on this, is they got the data lake, the lake house, they got the LLM there, and they have the Unity catalog, but all the good stuff that I put in my Unity catalog doesn't get factored into the LLM, right? So like, for example, if I want to do a query on that in natural language, I want to use tags, I can't, right? So kind of defeats the purpose of all this time I'm spending in my catalog for all that curation, right? So it's my one knock. Again, some of these I won't go through them line by line, but we'll share the slides. We'll have the recording, so you guys will have that. Snowflake, it's really strong SQL generation capabilities. If right now what we see is it's limited to a single database, which makes sense. That's kind of easy to start with. But if you're a customer with multiple databases, you might want to be able to leverage GenAI to be able to find and query things across multiple databases. So that's something that we think can be enhanced, right? And then the last one, again, it's in preview right now, is it's the SQL it's generating for you is sometimes it's just a suggestion. It won't actually run. And you see that with other tools is like they're really good at giving you a suggested SQL statement, but it's missing, for example, the actual fully qualified names that you need to actually run the query. So you kind of get a shell of a SQL statement, which you have to copy, and then you have to then go in and fill in, right, the actual fully qualified names. Not the end of the world, but again, it's not an automated experience, and it's not something you would give to a non-technical person who doesn't know the fully qualified names, or may screw up in typing the SQL syntax. So these are just things that you should consider, right, in terms of like who the audience is and at what step do you give this tool, right, to that audience. So now we want to talk about kind of a different approach, right? Which is the data fabric approach that Prometheum takes, where we will support multiple data sources because we do believe that not everyone has all their data, right, in a single warehouse or single lake. So it is important to be able to use GenAI to do text-to-SQL, where you can leverage the data regardless of where it is without moving the data, right? We do believe that if you're going to spend time updating, creating, building a data catalog with a lot of great tags and annotations and ratings and reviews, those are great signals and scoring guides to tell you this is the one that you should pick. Of the 60 revenue columns, this is the one, right? Of the 3 ways to join this table, join it on these 2 keys and do a left outer instead of inner, and here's why. That's awesome stuff, right? If you can incorporate that, you're going to get much relevant and much more accurate outputs, right? And then the last one I think is important is, a lot of these systems were built kind of pre-AI, pre-NLP, right? Where it was still dependent on a series of manual tasks that people had to do across a number of different teams. Whereas, a data fabric was always designed from the beginning to be a single interface, right? An NLP-driven interface, and one where the end user can actually go through the entire workflow if he or she wants to, end to end, using AI. So that's one of the considerations to think about in terms of a data fabric in using kind of GenAI generated text-to-SQL. And the cool thing is, like, there's a lot of synergies between the RAG architecture and the data fabric, as we talked about earlier, in terms of like the retrieval, the augmented generation. You're going to still leverage an LLM. You're still going to be able to do the natural language piece, but you're actually going to get better quality in terms of the data retrieval and the augmentation process, because you have the ability to leverage all the metadata, both active and passive metadata, and the curation that you've done, right? And then you actually have the ability to go beyond the code, right? Beyond, you can actually see the output, see the lineage, see the visualization visually, so that the users actually have more data points to be sure whether or not this is accurate or not, and then being able to do changes and iterate very quickly on the fly and train the system as it gets better. So, one of the things to think about is the fabric, because it's a newer architecture, actually out of the box has very, very good synergies in supporting kind of a RAG architecture. And so this is a basic architecture diagram of Prometheum, right? And so on the right-hand side is the customer environment, right, where you might have a bunch of different data sources, your BI tools, et cetera. On the right-hand side is the metadata control plane Prometheum, which we call the Prometheum scope, which only has the metadata. No data is there on our cloud. This is where our NLP engine is there. This is where we've figured out with our AI how to generate the text-to-SQL, which one is a better one to pick, which one's a better one to join, why, generate, right, that output. And this is where all the search and metadata operations are offloaded. And then in the middle, this box called the Intelligent Edge is also a Prometheum product, but it's always deployed in the customer's environment, right? In the customer's VPC. So that way, any type of data access will happen right behind the customer's firewall. They can control which ports they want open, close, IAM roles, all that good stuff. And so the way that this would happen in a data fabric architecture is the user will ask the question. And so that question, right, is generated and sent to the Prometheum scope, where, guess what, right? We have the NLP engine there, so we can parse the words into tokens, as we talked about, right, earlier, that second part of, the tokenization. Once we have the tokens, we can search it against the metadata index. So the metadata index has all the metadata from all your data sources that you connected Prometheum to. So it can now look at all the schema, usage metadata, user rating and review metadata for all the connected database, data warehouse, data lakes, right? For different levels that you want to expose the data fabric to. Tables, views, queries, even dashboards, right? And then based upon that, right, based upon that search and that matching of the tokens, right, Prometheum then, the reasoner determines, hey, I think these are probably the best tokens, right, that we have, right? Now the question, while we're doing this in parallel, right, when the user asks the question and we begin parsing, right, the question is also sent to the customer's LLM of choice, right? And you can either use a public, connect Prometheum to a public LLM like ChatGPT, or if the customer has their own specific LLM they want to use, you can connect that as well. So the LLM is going to parse the question and just suggest, here's how we would write the SQL expression based upon the question and the context and the intent of the question. So at this point, the LLM does not see your data. The LLM doesn't even see the tokens, right? And so the LLM has no idea what the table name, what the column names are, etc. It's just giving you these good natural language suggestions from a SQL perspective. So for example, if I want to know what's the top 10 selling products, top 10, right? That is a natural language expression that the LLM does a very good job telling you, here's how I would write the SQL for top 10, right? Best performing. Here's how I write the SQL for best performing. Show me, tell me. Those are things that the LLM is really good. Okay, I want to do a select, right? But it doesn't have the actual fully qualified name. So, there's nothing they can do with that violates any type of security, number one. Number two, you don't have to send data to the LLM if you don't want to. So at this point, it's very, very secure. And so now, because Prometheum is connected to your data sources and Prometheum now has all the active and passive metadata, as well as the ability to then query the data sources on demand. With all this combined, the data fabric is able to then return the SQL, right? And the SQL is now ready to be executed, regardless if the data comes from one or multiple sources. And so you can actually now verify whether or not the question you asked and the SQL that was generated by GenAI is actually functional, right? Which is pretty important, right? So, to kind of look at the automation, right? It's not, if you compare it to, let's go back a few screens. If you compare it to kind of the kind of data warehouse, data lake centric type of tools, right? All you're looking at in terms of the output is the SQL, right? And so the intended audience will probably have to be someone who is very SQL savvy, right? A data engineer, a hardcore data analyst. Whereas, when you ask the question Prometheum, in addition to a SQL, you're also going to get a visual lineage, right? We call it a data map, right? Here's how the data was assembled, right? Here the columns are selected from the tables that were selected. Here's how, the transformations that were done, right? The joins, the filters, the group bys, any aliasing, any casting, et cetera, that you would do. Here's a SQL that is generated, and a SQL generated instantly takes into account the ability to do federated queries. So you can actually query data without doing the ETL process, without moving the data yet. So instantly there. And then you can click run and it'll execute and show you the output. So there's a way for you to visually now verify the output as well. Okay, I asked for a vendor package. Did I get the revenue, right? Did I apply the right filters, et cetera. And then as a way to check, you can also ask the LLM to explain, why did you pick this? Tell me, based on the question, which tokens were measure tokens, which tokens were filter tokens, and why did you select this table? Did the data governance team like it? Did my data steward endorse it, right? Why did you join it this way? Has it been done before? Was it successful? Did people like it, right? So the data fabric actually brings an element of trustworthiness, right, and verification to it, as opposed to, just the SQL output, right? Which, could be okay, again, depending on the persona. But we feel that if you're going to allow the creation of the SQL statement that factors in all the relevant data, regardless of where it is, then people need to feel that they can trust it, right? And that's why we go through a great extent of actually doing the explainability, the lineage, as well as the SQL and the output, so that people feel comfortable with that, right? So the other thing that the fabric does is it gives you multiple modes to interact with, right? You can build, you can build halfway, you can have the LLM do all of it, right? You can just write code and have code assistance, right? Or, if you want, you can do a chat interface for someone who says, I don't even want to know how to use a UI. I just want to chat. Yes, no, select. That's it, right? So it also caters to a different persona that may not want to even mess around with clicking buttons, and that's fine. The cool part is, regardless of the persona, where they start, right? That creation, that generation of the SQL statement or the data set is going to be made available, if you want, based on roles and permissions, to different members of the team, right? As well as the context. Why did you ask it? Who asked it? What was your role in asking it? What was the topic of the question? And this is important because it now gives everyone on the team context. So if you're going to collaborate together, it's helpful, right? Oh, got it. You're on the marketing team. You're actually a somewhat SQL savvy person. You ask this question. This is what you're trying to do. Okay, I understand. So if I'm going to help you, I now have that context, right? Or, ooh, you shouldn't be asking that because let me tell you what all your other team members are asking, right? And so we feel that it's, even if you offer different modes of entry, it's important to actually allow the actual context of how the question was created, why it was created, as well as the data set, the output, in a way that is actually easy for people to see. So, what the LLM, and the data fabric does is it really gives you this real-time access, right? If you have the fabric here, it gives you this real-time access, and it gives you all the relevancy that we talked about, right? So all the things that we talked about earlier, where if you just put an LLM in the middle, you have some of these limitations. Well, this is where a fabric can come and provide some of the gaps that may be existing with the implementation that you may have today. Okay. So if you look at kind of the same kind of comparison, right, of say Prometheus data fabric, right, how does it compare to some of the other solutions out there? We definitely can allow you to do text-to-SQL off of raw tables. We definitely can allow you to do text-to-SQL off of pre-curated data sets, right? And not only do we generate the SQL, but we also generate the explanation. We allow you to fix it. You can do a lot of transformations in there. You can pipeline the data through generative AI. You can visualize through generative AI. You can narrate through generative AI. So it gives you a way to kind of see whether or not you can trust the output, right? Because if you can see it, you can move it to a different place to consume it. And if it does the explanation or the narration for you, it gives users a higher degree of trust, right? So those are kind of the raw capabilities and the consideration, right? Obviously, is if you can have the global discovery in the data fabric, you also now have the ability to generate SQL, not just from one source, but across many sources, right? And the best part is all that hard work that you did, your governance team did, someone did in the catalog, all that metadata gets leveraged in the building, right, of the SQL statement, in the building of the data sets, right? So that instant catalog to data access integration is there immediately, right? Which is one of the complaints if you talk to folks who use data catalogs. It's like, great, I found it. The metadata looks great. Now I want to access the data set. Oh, sorry, you can't do that. Now I want to build on it. Oh, sorry, you can't do that. That problem goes away, right? By having this deep integration. And then this type of, again, kind of talking about the extensiveness or the comprehensiveness of the SQL statement is you have to support all the main SQL functions, right? It can't be just select statements, right? So selects, joins, unions, case statements, filter, group by, et cetera, right? That all has to be supported for it to be, more functional to more than just the power users, because we believe GenAI, Text-to-SQL is great, but that convenience factor can benefit a lot of the non-technical folks, as well as the people who are SQL savvy, right? And so to do that, you have to allow the expression of their questions to be accurately generated from a SQL perspective. And that does sometimes include, oh, I'm going to need a case statement. Oh, I'm going to need a filter, et cetera, right? So again, I won't go through all this in detail, but basically all the things that a user will need to feel comfortable, to feel verification, to feel a bit of completeness in the workflow. Those are all the things that we have, right, in the data fabric. And it's, continually improving, but it's been in production for over 2 years. So it's not in preview. So something to kind of think about. And then recently we've added kind of the chatbot interface as well. So for users who don't even want to know what to click on, they just simply have to answer yes or no, and they can get through the complete workflow by themselves. And so here's an example of one of our customers. It's a Fortune 500 blood testing company where having a data fabric gives them the visibility across all their different data, but then having the fabric connect to all the data and being able to build, right, on demand, build that data set on demand, as well as query a pre-curated data set on demand, allows it so that they can actually allow anyone who has access to the fabric to simply query and consume data, right, via an easy chat interface. And so this allows them to respond to patient, physician, and also customer needs much, much faster. So there ends the presentation section. We can go into the demo section a little bit, do a very quick demo, and then we'll take some questions. So this is my demo environment. And again, the power of data fabric is you can connect to just about anything. So a bunch of relational data sources. I have cloud data sources. I have unstructured data like ClickHouse and stuff in S3 applications like Salesforce. The idea is that once you have the ability to connect to multiple sources, you want the ability to have discovery, right, across different sources. You want the ability to then, once you have the discovery, the ability to build, right? So I can say I want to look at, for everything that I have, I want to understand, not just the name, who updated it when, how often it was used, right? Where it's located. All those things should be available, and all that metadata should be captured and consumed. And not only that, you can also set rules on, hey, when I ask the question, when I search for something, how much weighting do I want to give something, right? So maybe my column names are not so good. Don't give it such a high weighting. Maybe my tags are really good, so give it a higher weighting, right? Or, I want to know that if someone really queries the heck out of something, make that a higher score for me. So this is all adjustable, right, by the user so that you can figure out what you want and how you want to rank it. And Promethean will take that as an input as we do the ranking and the selection. So imagine like you have all this metadata, you have both usage stats, you also have user ratings, right, like endorsements, et cetera. All that information, lineage information, already go from a metadata perspective, and then the ability to have data integration where whatever you have, even if you click on it, right, it's instantly queryable, right? So that way you're going beyond just metadata management. So that serves as a basis that now if you apply the LLM to, allows you to now put the LLM against this foundation to ask questions and to generate the output that you want. So let's say, for example, I want to know something, and the things that I want to know, for example, are in a number of these tables, right? I have some dimension tables, I have some fact tables, right? I have some measure tables in here, right? So the idea is, hey, I have a whole bunch of tables and I want to know something. I don't know exactly what I want to know yet, but I don't really want to go through and look at all these different columns and to figure it out. I want to be able to just ask a question. And so Promethean allows the user to do just that. So again, you can build leveraging that metadata management, that baseline, right? Either in a no-code way, the UI way, where we can suggest for you, for example, it said, hey, I'm trying to build something, and the first thing I want to start off with is I'm looking for something that's called revenue. Show me, based upon your quality score, which we call a reasoner score, what's the highest, and I only want tables, and maybe I only want things that my data stewards have endorsed, right? And so very quickly it narrows things down for you. Oh, okay, these are the two. Maybe you want to take a look at it and see whether or not this is going to give you what you're looking for. Maybe in addition to previewing the tables, it's not enough. So maybe we can automatically generate visual insights for you off of this. So you can see, oh, these are the type of questions I could possibly ask for this data. So that gives you an idea of, hey, is this what I want? And the user at that point could say, this is what I want, and select it and build from there. But if the user wants to use the GenAI mode, which they absolutely can, then I'm going to go ahead and get out of this here. I can simply select reasoner, right, which is our name for the LLM and GenAI assistant mode. And I can simply just type in my question here, right? And so the question I might want to ask, right, could be something like, hey, what's the average revenue? And I'm going to put a range so it doesn't pull everything back. So between 319. By vendor, by cancellation reason, by how they pay payment. Across a different range between Q4 2013 and Q3 2019, where payment is credited. So I basically want to know, tell me the revenue within a certain range, and show that to me by who sold it, what was the reason why a customer canceled, and within a certain time frame. And I only want to know for people who pay by credit card. This would be kind of an example of a natural language question that you would ask. And so you would simply click on Ask Reasoner, and Promethean will go and ask, figure out all those steps that we talked about, right? Sending the question to the LLM, right? Said, how would you do this from a SQL perspective? Parsing the question, right? So that's what it's doing right now in the analyzing. So analyze the question. So, okay, let's break it up into tokens. Now let's search the catalog for the tokens, and let's figure out the matches we have, and then figure out how we should put it together. And so now you have the ability to say, oh, okay, I believe to answer this question, you're going to need, right, this table from Postgres, this one from MySQL, this one from Oracle, and this one from Redshift. So from many different sources, and you can expand on them, right? These are the columns I'm selecting. This is the join key that I'm using and the type of join that I'm doing, right? And this is the filter that I have, right? You want to know between a certain date frame, Q4 2013 to Q3 2019. You wanted to know the revenue between 3 and 19. And you wanted to know only people who pay by credit card, right? And then you only want to see the data displayed, right, in this order, vendor, cancellation, payment. So this gives you that visual lineage that we were talking about. And you can also see the SQL as well that was automatically generated for you, right? And so it's doing some cool things, like it's obviously doing all the selects, right? It's identifying where to pick them from. It's doing the joins, right? And then it's doing things like casting, right? Because I wanted to express things like Q1, Q3. The data is not in that range, right? In terms of it's a timestamp, right? It's doing things like applying tags from your data catalog. Like, for example, the column is actually called MER, but everyone knows it as revenue, right? And then it's applying the filters, the time filters, right? The revenue filter, and then the payment filter, right? And payment was not, the column was not called payment, it was actually called billing method, right? So this is what the LLM and Promethean Data Fabric, RAI, the reasoner, has done. And here is the output that is generated, right? So you can visually view and see the output. Now you'll notice there's data map 1, there's data map 2, data map 3. And the reason for that is, like, within an enterprise where you have multiple data sources, there might be more than one way. And so, we will actually, data map 1 will always be the best way based on our AI and our scoring system. But we're also going to show you, hey, look, there's a couple other ways you can do it as well, right? So this would give you, the confidence to say, hey, this is how, whether or not, this is going to be more sufficient for us to answer the questions for our users, right? So this is an example of, building a data set off of raw tables, right? Knowing exactly where to pick them. Now, I could have done it a different way, and that is, you'll notice, I'll kind of go back to here. The data I put into a logical grouping called a domain, right? Called demo, right? So in the first demo I did, I said, hey, search across everything and tell me the best way to put this together. And that's why we gave you 3 choices. Now, I could have done this and said, hey, I only, Prometheum, I only want you to look within this logical grouping called demo. And I could select multiple, multiple domains if I want to as well. So when I do that, then it's going to be a lot more focused, right? So this helps with hallucination because it limits the LLM and the search against a specific set of data, which again, logical grouping, right? In this case, I group based upon a topic, right? Called demo, right? Even though they come from different sources or different names. So you notice when I do this, I don't have data map 2, I don't have data map 3, I just have 1, right? So this also allows users to kind of control how to make sure you get much more relevant, much more focused information. So if you want to give this to someone to use who's not technical, maybe one recommendation is, create domains for the data that you have, right? And it's very, very easy to do something like that, right? When whatever tables, views, queries that Prometheum is connected to and exposed to, right? You've got the ability to kind of select the different domains that you may want, right? You can even have subdomains as well. So this gives you a lot of flexibility in terms of just grouping the data in a way. Okay, I think we have 5 minutes left, 6 minutes left, 7 minutes left. I'm gonna, take some questions and see if there's any questions. Q&A. All right. Can I elaborate on Prometheum's AI-powered workflow and how it simplifies query generation compared to other solutions that rely on the manual task? Yes, I can. I think I actually showed it in the demo, right? But as you can see, we do a lot of workflow automation, right? From the asking the question, you did not have to go into a catalog to search for the data, right? That was whatever metadata, active, passive metadata, user ratings, that was then factored in, right? Query history, consumption history, that was factored in. Previous joins that someone might have that has higher weighting, that gets factored in for you already. And then we generated that output, and then we generated multiple outputs to show you that, hey, these are possible routes. So we didn't have to wait for someone to do that. There's no extra step you need to take if the data is from multiple sources. You can simply just say, hey, regardless if I'm doing this on one source or multiple source, the workflow is exactly the same. Excuse me. And then from there on, you can kind of go one step further, right? So if you wanted to send this to Power BI, Tableau, Looker, etc., right? You can just simply click one button called Publish, right? I'll show that in my, let me show this here again. Right, so let's see if I have like a data map that was created and I want to run this, right? I simply just have to publish this. And once I publish, any BI tool that is connected to Prometheum, BI tool will treat Prometheum as a database, as a data source, can instantly grab this output and visualize. So that way it doesn't have to do any more transformation. It can actually alleviate saving all that compute process and that transformation, and it can just simply visualize. You can also, if you want to, you can also take one step further and say, hey, I want to build an answer. So with Prometheum, you can say, I want to do the next step in the workflow, which is package this up together for me as a data product. So that way it becomes easy for people to search, easy for people to interact with, right? And then also make it so that way, if I wanted to, right, I can build dashboards against it, right? So it gives you that level of automation, right, to be able to create the dashboards. So if I wanted to do this, sum by revenue by, say, package, right? I can easily create the visualization here on the fly And then once I save this, right, it'll be in the dashboard section. So now I'll have a data product that will have both the query that I generated, the output, and the visualization. So now it becomes a searchable asset, and from a product perspective, that includes more than just the SQL statement. Okay, let's see. What else do we have in terms of questions? Does this mean I have to have yet another data store to manage, or can this work without replicating data to Prometheum? Correct. So Prometheum never, ever, ever asks you to move data or store data within Prometheum. So this will work seamlessly in your existing database, data warehouse, data lake, Salesforce, and other SaaS applications and BI tools. So you do not ever need to move data into Prometheum. We're not going to be another ETL process. We're not going to be another data warehouse or data lake. Okay. What does the initial configuration and setup look like for connecting to several data sources? What catalogs, metadata, etc.? Okay, so it's a good question. So we have a very easy wizard here for you to go connect to different data sources, right? You simply, it's all UI driven. We have a number of different sources, and if something is generic, you can always just use like, generic JDBC, for example, or generic S3, for example, and that will work. But you can simply select on which data source that you want to be able to connect to, and then input things like name, descriptions, account information like that. And so you do have to make sure you work with someone in IT that's got the proper credentials. You want to make sure that the user has the proper credentials. And then once you do, you can then set up role-based or fine-grained access control. So that way that, even though you have a connection to the source, it doesn't mean everyone can see everything in that source. And once that's done, you instantly get this. You instantly get the ability to search for the tables of views and queries within that data source. Now you still have a choice to choose, which schemas you want to limit Prometheum to. That's fine. But now you have that. As when people update, it'll update the time frame, the timestamp when it was updated, who updated by. As when people query, it will update the query count. But it'll capture metadata like how many rows, how many tags, how many fields, and location. That gets created for you instantly. So hopefully that answers Anandip's question. Okay, Sujay says, is Prometheum using metadata tools as an input to parse the information tables, joins that are endorsed, etc., or does Prometheum run agents to build metadata for each how it take or changes? Good question. So the answer is both, right? Either or, I should say. So you can actually use this catalog here that captures all the machine-generated metadata as well as user-generated metadata. Or if you have like an existing data catalog like Libra or Relation, we can import the metadata information that you have. So that way, right off the bat, you can have that. Or we can get, for example, access metadata information, right? From like your Snowflake data source, or even, something like, if you're using, say, Tableau, right? You can even get dashboards like Tableau, as you can add that as a data source, and as you can now instantly get the refreshed metadata in terms of kind of how often dashboards been used and what data sets power that dashboard, for example. So we do help customers who don't have a catalog or metadata management tool by offering one, but you certainly can apply your existing metadata management tool and leverage what you already have, which if you have one, I would recommend that, because someone spent a lot of time putting all that information in. And so I would definitely recommend, leveraging all the years of curation that someone has done in giving us that metadata as a good start to start off with. But again, not necessary if you don't have it. Those are some of the things that we will do, or we use our AI to kind of figure out the best possible joins, right? Based upon the context of the question you're asking, based on the data that we see. So We try to give you as much out of the box without you doing anything. But if you already have existing metadata, we'll take it. And then if you don't have any of that, it's pure, then the first time you might have to build that data set and show us, right? Maybe load existing queries into Promethean. And once you do, that's going to give us a history of all your previous joins. And so next time we see a question being asked where it requires a join between two tables that we've seen in one of your previous queries, we'll instantly know, hey, that's the right join key that we're going to use because we've seen it before. So you can kind of fast start Promethean by preloading some of the existing queries that you have. Okay. Great. Well, I think that does it for all the questions that we have. And again, this will be recorded. This is recorded, and we'll be sending it out. And this is, episode 1 of many. So if you guys have any feedback or suggestions in terms of other questions that you guys would love for us to address, we will be more than happy to put that into the future episodes. So thank you guys so much for spending this time with us. Take care and be safe.